The James Webb Space Telescope just broke physics. And I'm not being dramatic here. What it captured shouldn't exist, can't exist, not according to every law we've spent centuries proving. Nobel Prize winners are scrambling, textbooks are being questioned, and the images coming back from deep space are showing us something that defies the very timeline of creation itself. What Webb found isn't just older than expected, it's older than possible. Stay with me, because what I'm about to show you will change how you see reality. Before we dive into this cosmic mystery, smash that like button and subscribe, because this channel is where we explore the discoveries that mainstream science is still trying to process. Here's what happened. Webb pointed its infrared eye at a region of space so distant, so ancient, that light from there has been traveling for over 13.5 billion years to reach us. We're talking about looking back to when the universe was barely 300 million years old, a cosmic infant. And at that age, according to everything we know, the universe should have been relatively empty, simple, primitive. But that's not what Webb saw. Instead, it captured fully formed supermassive black holes. Not little ones, not baby black holes slowly growing over billions of years like our models predict. No, these monsters were already billions times the mass of our sun, already feeding, already spinning at the centers of organized galaxies. And here's the problem. There wasn't enough time for them to exist. Dr. Priyamvada Natarajan from Yale, one of the leading astrophysicists studying black hole formation, looked at this data and said something that sent shockwaves through the scientific community. She said these black holes are appearing embarrassingly early. That's not hyperbole. That's a scientist admitting we have no idea how this happened. Think about what that means. The Big Bang happened 13.8 billion years ago. These black holes Webb detected existed when the universe was only 300 to 400 million years old. In cosmic terms, that's the blink of an eye. To put it in perspective, if the entire history of the universe were compressed into 1 year, these black holes would have formed by January 8th. The universe was basically still waking up. And yet, there they were. Supermassive, powerful, fully operational. Here's why this breaks everything. Black holes don't just pop into existence. They form when massive stars collapse at the end of their lives. Those stars need time to be born, to burn through their fuel, and then to die spectacularly in supernovae. Only then do they leave behind black holes. And for those black holes to grow into supermassive ones, they need millions, even billions of years to feed on surrounding matter and merge with other black holes. But Webb is showing us black holes that are already supermassive when the universe was a toddler. The math doesn't work. The timeline doesn't work. The physics we've relied on for a century doesn't work. And it gets weirder. Some of these early black holes are growing faster than the Eddington limit. Now, if you're not familiar with that term, let me break it down. The Eddington limit is basically the speed limit for how fast a black hole can grow. When a black hole feeds, the material falling in gets superheated and releases radiation. That radiation pushes back against the infalling material. It creates a kind of traffic jam that limits how quickly the black hole can consume matter. But these ancient black holes Webb discovered, they don't care about that limit. They're breaking it, growing faster than should be physically possible. It's like watching a newborn baby suddenly bench press 500 pounds. It violates the rules. Nobel laureate Roger Penrose, one of the greatest minds in theoretical physics, recently commented on these findings, and his reaction was telling. He didn't try to explain them away, he didn't offer a quick solution. He simply acknowledged that what we're seeing suggests our understanding of the early universe is fundamentally incomplete. Let that sink in. One of the architects of black hole physics is saying we might have gotten something big wrong. So what's going on here? How can the universe show us things that shouldn't exist according to its own rules? There are a few wild theories starting to emerge, and trust me, each one is more mind-bending than the last. Let's talk about what scientists are now forced to consider. Because when the evidence doesn't fit the theory, you don't ignore the evidence. You question the theory. And right now, some of the most fundamental theories in cosmology are under serious fire. Theory number 1. Direct collapse black holes. This idea suggests that under certain extreme conditions in the early universe, massive clouds of gas could have collapsed directly into black holes without ever forming stars first. Skip the middleman entirely. These would be born big, immediately weighing hundreds of thousands or even millions of solar masses from day one. Now, this isn't a new concept. Scientists have theorized about direct collapse black holes for years, but they were thought to be rare, extremely rare, and they required very specific conditions, pristine gas clouds with no heavy elements, trapped in massive dark matter halos. But if Webb is detecting multiple supermassive black holes this early, it means direct collapse wasn't rare at all. It might have been the norm, the universe's default setting. And if that's true, then our entire model of how structure formed in the cosmos needs a complete overhaul. But here's the catch. Even direct collapse black holes need time to grow into the monsters Webb detected, and there still might not be enough time, which brings us to theory number 2. What if these black holes didn't form after the Big Bang at all? What if they formed before it? I know that sounds insane, but hear me out. There's a concept called primordial black holes. These are black holes that could have formed in the first fraction of a second after the Big Bang, during the intense quantum fluctuations of the newborn universe. Not from stars, not from gas clouds, but from pure density fluctuations in space-time itself. If primordial black holes exist, and if they were massive enough, they could serve as the seeds for the supermassive black holes Webb is detecting. They'd have a head start, a cosmic cheat code that bypasses all the normal growth timelines. Stephen Hawking proposed this idea decades ago, and for years it was considered a fringe theory. Interesting, but unprovable. But now, with Webb's data staring us in the face, primordial black holes are getting a serious second look. Some physicists are even suggesting they could solve another massive mystery: dark matter. What if a significant chunk of the universe's missing mass isn't some exotic particle we've never detected? What if it's just primordial black holes, small, invisible, scattered throughout the cosmos? It's elegant, it's testable, and it's absolutely terrifying in its implications. Because if primordial black holes are real and abundant, it means the universe's first moments were far more violent and chaotic than we ever imagined. But there's an even stranger possibility. Theory number 3. What if time itself worked differently in the early universe? This is where things get truly wild. Some cosmologists are now suggesting that the flow of time might not have been constant in the universe's infancy, that the very ticking of the cosmic clock could have been different, faster, more compressed. If time dilated differently near the Big Bang, then what looks like 300 million years to us might have functioned like billions of years in the early universe, enough time for these black holes to form and grow through normal processes. But from our perspective, looking back, it appears impossibly fast. This idea ties into theories about varying speed of light, non-uniform expansion, and quantum gravity effects that we barely understand. It's speculative, it's controversial, but the fact that serious physicists are even discussing it tells you how desperate the situation has become. And then there's the nuclear option, the theory that some scientists don't even want to say out loud. What if the Big Bang wasn't the beginning? What if our universe is cyclic? What if it's been through this before? What if these supermassive black holes are remnants from a previous universe, surviving through a cosmic bounce or a phase transition we can't yet comprehend? This isn't science fiction. Roger Penrose himself has proposed the model called conformal cyclic cosmology, the idea that our universe is just one eon in an infinite series of universes, each born from the death of the one before it. And if that's true, then these ancient black holes might be echoes, fossils, survivors from a cosmos that existed before our own Big Bang. Think about that for a second. What Webb might be showing us isn't the earliest moments of our universe at all. It might be the dying breath of the universe that came before ours. And here's the thing. We have no way to prove or disprove this yet, but the fact that Nobel Prize winners are taking it seriously should tell you something. The data from Webb isn't just surprising, It's paradigm-shattering.
Now, if you're thinking, okay, so there are some old black holes we didn't expect, big deal, let me explain why this discovery ripples through everything. Because black holes don't exist in isolation. They shape galaxies, they regulate star formation, they influence the distribution of matter across cosmic scales. If we got black holes wrong, we got galaxies wrong. If we got galaxies wrong, we got the entire evolution of structure in the universe wrong. And Webb's data is confirming exactly that. Remember how I mentioned that these black holes appear at the centers of organized galaxies? That shouldn't be possible either. The old model said galaxies formed first, slowly pulling together over hundreds of millions of years, and then black holes formed at their centers much later. But Webb is showing us the opposite. Black holes first, galaxies second. It's like finding the foundation of a building sitting on top of the roof. The order is backwards. And this has massive implications for how we understand galactic evolution. For decades, we've known there's a tight relationship between the mass of a galaxy's central black hole and the mass of the galaxy itself. We called it the M-sigma relation, and we assumed galaxies grew first and dragged black holes along for the ride. But what if it's the other way around? What if black holes came first and built galaxies around themselves? What if these supermassive black holes acted as gravitational seeds, pulling in gas and dark matter, triggering star formation, and essentially constructing the galaxies we see today? If that's true, then black holes aren't just cosmic monsters, they're cosmic architects, the master builders of everything we see, and that completely flips our understanding of cosmic structure formation. But the implications go even deeper. Let's talk about dark matter, that invisible substance that makes up 85% of the matter in the universe. We've spent decades searching for it, building detectors deep underground, smashing particles in accelerators, and we've found nothing. Not a single confirmed detection. But what if we've been looking for the wrong thing? What if dark matter is just primordial black holes? What if the missing mass of the universe isn't some exotic particle, but a population of black holes formed in the first moments after the Big Bang, too small to detect directly, but massive enough collectively to shape the cosmos? It's not a new idea, but Webb's discovery of supermassive black holes breathes new life into it. Because if primordial black holes can explain both dark matter and the early supermassive black holes, that's one theory solving two massive problems. Occam's razor at work, the simplest explanation that fits the data. And then there's the Hubble tension. You might have heard about this. It's one of the biggest controversies in cosmology right now. When we measure the expansion rate of the universe by looking at distant galaxies, we get one number. When we measure it using the cosmic microwave background, the afterglow of the Big Bang, we get a different number. They don't match, and the gap is widening. Some scientists thought this was just a measurement error, a calibration issue. But as the data gets better, the tension gets worse. And now, with Webb showing us that the early universe was far more complex than we thought, some physicists are wondering if the Hubble tension is telling us something fundamental. What if the expansion rate of the universe wasn't constant? What if it changed? What if the early universe expanded differently than our models predict? If supermassive black holes existed earlier than possible, it suggests the universe's early conditions were radically different from what we've assumed. Different density, different temperature, different expansion dynamics. And if that's true, then the cosmic microwave background, our most treasured piece of evidence for the Big Bang, might need to be reinterpreted. Not thrown out, but reinterpreted, adjusted, corrected for factors we didn't know existed. And here's where it gets uncomfortable for a lot of scientists. This isn't just about fixing a few equations or tweaking a model. This is about admitting that some of our cherished assumptions might be wrong, that the story we've been telling about the universe for decades might be incomplete. The Big Bang itself isn't being questioned. The evidence for it is overwhelming. The expansion of the universe, the cosmic microwave background, the abundance of light elements, all of that still holds. But the details? The timeline, the mechanisms, those are suddenly up for debate in a way they haven't been since the 1960s. And scientists are doing what scientists do. They're arguing, they're debating, they're proposing wild new theories and tearing each other's ideas apart. It's messy, It's chaotic, but it's also how progress happens. Because here's the truth. Science isn't about having all the answers. It's about asking better questions. And Webb is forcing us to ask questions we never thought we'd need to ask.
So where does this leave us? What happens next? First, let's be clear about one thing. This isn't a crisis. This is an opportunity. The James Webb Space Telescope is doing exactly what it was designed to do. It's pushing the boundaries of human knowledge. It's revealing the universe in ways we've never seen before. And yes, sometimes that means discovering things that don't fit our expectations. But that's not a failure of science. That's science working exactly as it should. The next steps are already in motion. Astronomers are planning follow-up observations of these ancient black holes. They're looking for more of them, studying their properties, measuring their masses more precisely, trying to understand their environment. Every new data point brings us closer to solving the puzzle. And theorists, they're having a field day. Papers are being published at a breakneck pace. New models are being proposed. Old models are being dusted off and reconsidered. This is cosmology's most exciting moment in decades, maybe since the discovery of cosmic acceleration in the late 1990s. But beyond the science, there's something deeply human happening here. We're being reminded of our place in the cosmos, and it's humbling. For all our technology, for all our intelligence, for all our achievements, we're still just scratching the surface of understanding. The universe is bigger, stranger, and more mysterious than we ever imagined. And every time we think we've got it figured out, it shows us something that makes us question everything. These supermassive black holes existing when they shouldn't, they're not just anomalies, they're messengers. They're telling us that the universe's first chapter is more epic, more violent, more extraordinary than we gave it credit for. They're evidence that the cosmos doesn't play by the rules we thought we'd written. And maybe that's the ultimate lesson here. The universe doesn't owe us easy answers. It doesn't care if our theories are elegant or our models are clean. It just is. And our job, as curious beings lucky enough to witness it, is to keep looking, keep questioning, keep pushing forward, even when the data challenges everything we thought we knew. So, what do I think is happening? Honestly, I think we're seeing evidence of physics we don't fully understand yet. I think the early universe operated under conditions so extreme that our current theories are incomplete. Not wrong, just incomplete. I think these black holes are real. They existed, they shaped galaxies, and they're forcing us to expand our understanding of how matter, gravity, and time itself behaved in the cosmos's first moments. Are they primordial black holes from before the Big Bang? Maybe. Are they direct collapse black holes that formed impossibly fast? Possibly. Is there some other explanation we haven't thought of yet? Absolutely. The beauty of science is that we don't have to guess. We can test, we can observe, we can build better instruments and look deeper, and that's exactly what's happening. Webb is just getting started. It's been operational for just over 2 years. Its mission is planned to last a decade, maybe longer. And every year it's going to show us more ancient galaxies, more mysterious objects, more cosmic puzzles that don't fit our expectations. And each discovery will refine our understanding. Each observation will bring us closer to the truth. Not the comfortable truth, not the easy truth, but the real truth, the one written in the fabric of space-time itself. So here's my challenge to you. Don't be afraid of these discoveries that shake our foundations. Embrace them, celebrate them, because they represent humanity at its best, using technology, intelligence, and sheer determination to peer into the deepest mysteries of existence. We live in an era where we can look back nearly to the beginning of time itself, where we can detect black holes billions of light years away, where we can ask questions our ancestors couldn't even dream of. And the fact that the answers are complicated, the fact that they challenge us, that's not a problem, that's the point.
The universe is under no obligation to make sense to us, but we are determined to make sense of it anyway, and discoveries like this, as confusing and paradigm-shifting as they are, prove that we're on the right track. So, what do you think? Are these black holes evidence of primordial seeds from before the Big Bang? Are they telling us that time worked differently in the early universe? Or is there some other explanation waiting to be discovered? Drop your thoughts in the comments. I read every single one. And if this video opened your mind to the cosmic mysteries we're still unraveling, hit that subscribe button, because we're living through the golden age of space discovery, and I promise you, the best is yet to come. Thanks for watching. And remember, every time we look deeper into space, we're looking deeper into time. And what we're finding there is stranger than any science fiction writer ever imagined. The universe isn't done surprising us. In fact, I think the real shocks are still waiting in the data we haven't analyzed yet. See you in the next video. Keep looking up.